Okay. So that's some very most elementary problem for vector addition. Okay. We just add 2 or 3 vectors. Yes, these are elementary vectors. Okay, and by the way, we are only dealing with vectors with only 2 components. We have only x and y components. We didn't need even put the z component. Okay, and in fact, in the advanced physics, sometimes you are going to deal with some very horrible vectors. In the general relativity, theory of general relativity, you are going to deal with the so-called tensor, where you will have 16 components. So you are going to instead of have x component and y component, you have component 1, component 2, component 3, component 16.
Oof.
Okay, and then you are going to deal with more complicated calculation. How to multiply 2 vectors? Here we only n vectors. So they are just some elementary indications. But you have to do a lot of practice because it's quite different with our algebra here. So just do the homework. Now, let's do the next part. Okay? Any question here? We have this problem again. We'll deal with the relative velocity. Okay, but the main idea here is still to deal with this problem in terms of vector addition. So that's why the vector addition is one of the most important things for us, because when you solve the problem finally, when you formulate it, it will become some vector manipulation. Okay, you just deal with different kind of vectors. Sometimes you're going to deal with force vector. Sometimes you are going to deal with velocity vector. First, the water in the river flows at a speed of 6 meters per second. A boat moves downstream at a speed of 8 meters per second relative to the water. What is the velocity of the boat relative to the ground? Okay, this is in fact is quite a simple question. I just want to use this to illustrate what we mean by relative speed. So A, if the river flows with 6 meters per second, okay, and the boat is moving relative to the water with 8 meters per second. So relative to the ground or the bank, what is the velocity of the boat? So that is just 40 meters per second. Okay. So that's what I mean by the relative velocity. If this is moving relative to this, and this is moving And you understand, negative here means the speed, the velocity of the boat relative to the ground is in this direction. Okay? That's for part E. Any question here? Now? Yeah, negative, yes. Yeah, but yes, it is with the direction. And the negative here, that means the boat is faster than water. Because you choose positive to that direction, to downstream, and the boat is upstream. So it should, in those coordinates, should be coordinated. Okay? So again here, please make sure you understand what we mean by negative positive. Negative doesn't mean it's lower than water, it just means it's in that particular direction. Okay, part C. A boat moves at a speed of 6 meters per second relative to the water, and it is perpendicular to the direction of the water flow. What is the velocity of the boat relative to the ground? So the situation should be something like that. Water flows 6 meters per second, like this. And the boat now is heading to perpendicular to the water flow. Okay, this way with what's that? 6 meters. Okay, 6 meters per second. Okay. And what is the speed of the velocity of the boat? So you can see what happens now. In this case, the water mixes close to the right direction, and the boat goes this direction. So the final effect will be something, the boat will go something like that, right? So the boat will go like this way, in fact. Okay? And this can be regarded as the vector addition of two velocities. Okay? This is, because this is A, and this is B, okay? Two different velocities. Now you add them, so the total, the velocity relative to the ground, in this case, is A plus B. Again, in any case, it's A plus B. But in this case, you have to do the vector calculation. Any question here? So of course, you have to do the decomposition. And if you make the coordinates like the positive x to the downstream direction, positive y is perpendicular to it in the direction of the boat. So A is like this, right? And B is like this, right? So you are going to add the two vectors, A and B. Any question here for the what you are doing for this problem? Okay, and then the first stage to add the vector is, what's the first stage to add the vector? We have three different stages. Decomposition. In this case, the decomposition is quite straightforward for both. So AX, AY, BX, BY should be very easy to tell. What is AX? Okay. What is AY? 0. What is BX? 0. What is dy? Right? Because both vectors are along axis, so you don't even have to do any calculation, you can get the component. Now the second is to add x component and y component separately. Again, it's very straightforward. So Cx should be Ax plus Bx equal to 6, and Cy should be Ay plus By, so 0 plus 6 equals to 6, right? Okay? Last stage is to find the magnitude from Cx and Cy using Pythagorean theorem. So C equals to square root of 6 squared plus 6 squared. Okay? So 6 to multiplied by square root of 2 meter. Okay? So the velocity of the boat relative to the ground should be the 6 square root of 2. Any question here? Okay, so think about all these problems. Every time the key is that we can convert this physical problem to some vector addition and use the general rule we learned here to solve the problem. Okay? So let's just start.